So this is week 13. Next week we have no class, Thanksgiving holiday. Okay. All right. So begin. So since we finish a big section about a linear line, we have a big section. This part is finished. All right. Earlier we talked about linear line and linear line system and linear line inequality, linear inequality, in graphing system of linear inequality. All we talked about is linear line. So right now we want to move a new topic. Actually is the exponent. Excuse me. Exponent. Excuse me. Exponent. Did anyone learn exponent before? Yes, right. I believe you guys learn exponent. So what's the exponent? What's the exponent? So let me give a quick example about the numbers. You guys definitely learn about exponents, right? Okay, so something like say 2 times 2. We often got a 4, right? So actually equals 2 squared, right? And if you say got a 3 2, so actually 2 cubic power 3, right? Right. So if let's say number, multi-same number time together, we can describe like this way, right? So if less, so that's actually 1 right here. 1 2 power 1, 2 power 1, 2 power 1. The product of this one. So these 3 come where? Come the product of the sum of this each of the exponent, right? So if I have say 2 times 2 times 2, that's a lot of 2. Here, let's n2 times together. So it would have become 2 power n, right? 2 power n. 2 power n. Did you guys learn this one? You learned this one already, right? Okay. So right now we say have x number, a time together. So it's became 2, not 2, right? Not 2. Actually, it's became x squared. If less x times x, less n of the x times product of them will be x power n. Is it correct? Right? Right? So everyone can understand this one. So here, just like the number 2, 3 of the 2, product of them is 2 power 3 or cubic, or 2 cubic, 2 power cubic, or 2 power 3. If less n, actually 2 power n. So this one, this number, we call exponent, exponent. So this is the, so anyone thinks something like this one. So this is the base and this is the exponent, right? Exponent. They can add something like say, if you have 2 times here, 2 times here, it's 2 times here. There's a 2 in front of here. If you 2 in front of here, so here 2 times here. So here it became a term. It became a term, but we talked about term a little bit later. Let's talk about exponent first. So x power n, x power n. All right. So this is a kind of exponent. Actually, there's a base, there's a power rule here, right? A power rule here. N is the exponent. It means have n number, n unit n of the x, the product together, right? Product together. So they have the operations as well. So when they do product, if they have this, say, I'm sorry, I mean use a different color, that's not good. So if let's say, if you say have 2 square times 2 power 3, this equals what? You guys can find out what's the number should be here. Okay, guys, unmute yourself. Can you guys answer me? Max, what's the answer of here? Max. Nobody answer me, huh? So actually, see this one. So you can see here is 2 times 2, right? And what about this one? It's 2 times 2 times 2, have 3 of them, at least 2 of them. So actually, this is 2 power 5, right? So actually, here is 2 power 5 as well, right? You can break it down. 2 times 2 times, here actually 3 of the 2. So actually 2 power 5. So here also 2 power 5. They are the same, right? So where does this 5 come from? Actually, it comes from 2 plus 3. So 2 plus 3. Okay. So if less n times m, so there is product is like this, m plus n, right? M plus m, right? Is it correct? So this is exponent part is product of them, is the sum of them, sum of the exponent. You can find out here. So the same here, if x squared times x cubic. So what's the product here? So also 5, right? Because here is x times x. Here is x times x times x. So the result is x power 5. So this 5 the same. It's also come from 2 plus 3. So it's xn times xm. This one equals what? M plus m, right? So exponent part. So here is exponent part. Actually, exponent part. So when they product, the exponent became the sum of them together. So with this called product rule. Product rule. So, all right, so keep this in mind. This is exactly the same as learning you in other area as well. This, you can break it down this one. This is n kinds of x product together, times m kinds of x product together. So equals to total is n plus m kinds of x product together, right? Okay, okay, all right. So let's say second example. So we let 2 power 3. We will not say product, right? With times easy to break it down, right? What about divide? Quotient, find the quotient. When they do the divide, something like 2 divided here. So actually the top part actually is 2 times 2 times 2, right? What about bottom part? 2 times 2, so equals 2, right? 2 actually 2 power 1, here is 1 power here. So actually this part is means, this part is 3 2 minus 2 2. So actually this one is come from 3 minus 2, right? This one actually comes 3 minus 2. So actually 2 power 3, we can write here, this 2, 3 minus this 2, right? This 3 minus this 2, so you got a 2. Okay, so actually, so if they have x power 3, x divided 2, so equals what? So actually this one you can see is 3x, right? Product, and this is 2x product. After simplify, so you got an x, right? This x is come from 3 minus, here actually is 1 here. So 1 is come from 3 minus 2, right? That's the same. So if we give their quotient, so something like say x power 3 divide x power 2 actually is come from 3 minus 2, right? So exactly this is described here. So if I say let's mx divide n x power n, so what's that? So actually it's m minus n, right? Minus n. So this is called quotient, actually divide. They call quotient rule. Quotient rule. Second one. The first one, we need to keep this in mind. Huh? This is what we this is the same as what you learn about exponent. Just keep this in mind. When they product rule, when they have n, x power n, x power m, the product of them. So the base didn't change, right? The base didn't change. The exponent part is sum of them. When they do the divide, do the quotient, when they base the same, the exponent part is just minus, right? Minus. All right, let's go move on a little bit more. Okay. All right, so I summarize here. So first, when x m times n equals m plus n, right? When they divide, it became minus, right? Top minus bottom. Okay. The third one, let's see the power rule. Power rule. What's power rule? When we say 2 square power, let me see 3 cubic. Do you guys what this means? We extended this part, right? Let me give one base first. Let me not give so complicated. And I use a square. Did you guys see here? Here means what? Did you guys do? Can you guys do this one? This one means this part, the base part, times square, right? It's this part, 2 of them, square. This we consider this is the base, square. This means 2 of them, right? These 2 means this one is here, the other one is here, right? So here you got a 2, actually power 4. Based on these rules, 2 plus 2, so we got a 4, right? Actually have 2 here and 2 times here, so you got a 2 power 4. What about this part? They are cubic. Did you guys got this one? The cubic. Cubic means what? It means 2 power 2 square and 2 square. 3 of them, right? 3 of them product them together. So actually result would be what? 2 plus 2 plus 2, right? So 2 plus 2 plus 2. Actually 2 power 6. Right? All right, so right now I changed. This is how to see this one. So the inside one is x power n, right? X power n, 3 of them, right? Cubic. So it became what? So use these rules again. So x n plus n, right? Became 3n. So you can, if you connect this one to this one directly, what do you find? So let me rewrite it here. It's just like this one time this one, right? Time. This is called power rule. So if I, this one, that's actually is m. This one is became m. Became what? So actually is n times m, right? We call this power rule. Power rule. So x m power n. So x equals m times n, right? So you can see this is the product rule. This is quotient rule. This is what? This is power rule. Power rule. Okay. All right. Did you guys see this one? So you can see this is three basic. Keep this in mind, right? Keep this in your mind. So let me have one question here. Let's see this question here. So if the m equal n, if m equal n, we know this one equal, use the quantity rule is like this, right? If m exactly equal n, if m equal n, we n replaced by m, right? So here it means for m minus m, right? M minus m equals 0. Actually, this number is the same. So actually this equal 1, right? Top and bottom is exactly the same. So it means this equal 1. Right? Right? Is it correct? So it means any number except this is 0, right? Except this x is 0. If their exponent is 0, the result will be equal 1. Of course, x cannot equal 0. Just like the base cannot equal 0, because x equals 0 in this denominator will be equal 0. That's meaningless, right? So we cannot let x equal 0. So it means when the base not equal 0 condition, any powers of 0 will be equal 1. So we introduce the fourth rule. Any number, if their exponent is 0, equal 1. Just like this base cannot equal 0. All right. So we have 4 of these kinds of together. Exponent rule together already. Right. So that's very critical. So keep this. Use some typical examples you learned before, so you can get a more basic understanding what's going on here. All right. All right. So let's move on a little bit more. About exponent. Exponent right now, we in our mind is like a number they product or divide multi times, right? So x power n. Earlier we only learned is 1. Right now we go bigger numbers, something like x squared, x cubic, x5, right? So you can see this number earlier when we drew a linear line, always is 1 with say ax plus by equals c. Here is 1, right? Power only 1. So we go higher level. So we call this is degree. This is n, actually is something that we also call degree. Earlier we learned 1 degree. The degree is 1. Degree is 1 for a linear line, right? So right now the degree is increasing, sometimes even bigger. All right. So we give them a little bit more information here. So just keep this in mind, it's fine. We don't necessarily go that far yet, all right? We only keep this product rule, quotient rule, power rule, and 0 rule. 0 exponent rule. All right. So these 4 of them, keep it in your mind. You keep it in this mind, the base is the same. When we do this one, you can see the base is the same. Base is the same. Only the exponent part, power part, do some calculations. Do the operations. Okay. So right now we talk to a little bit further. What further? All right. Right now we're talking about We're talking about, say, base is only 1, right? What about 2? Well, let's give an example, say 6 squared. 6 squared. So equals 36. Everyone can understand this one, right? Right now, we say 6 actually is 2 times 3, right? 2 times 3 squared. What do we do? Actually, this one, we can break it down into 2 squared times 3 squared, right? Do you know how we do that? Okay, so let's do like this way. Because 6 equal 2 times 6, so actually is, let me rewrite this part. Before I rewrite it, actually this one is 2 times 3 times 2 times 3. This is 6 times 6, right? So we do the commutative property. We adjust. So 2 times 2 times 3 times 3, right? So 2 times 2, 3 times 3. So 2 times 2 became here, 3 times 3 became here. So if you compare these kinds of equation, what do you find? Just like each, when this base factored, they can factor into 2 times 3. And when they do the power, each of the factor power itself, right? 2 power 2 square, 3 square, right? Because even breaking down, you can see this is 2 times 3, 2 times 3. And do the commutative, put this position, switch a little bit. So you can 2 times 2, 3 times 3. So actually it's 2 square times 3 square. So, all right, so I can say A times B square. Actually, this one means what? Each of them need a square, right? Each of them need a square. So if each of them powers of n, so it means each of them power separately, power n separately, right? Right? Is it correct? Thinking about this one. So the result here, definitely is also 36 as well, because of 4 times 9, right? This is 4, this is 9, 36. 6 times 6, 36. Definitely this makes sense, right? All right. So most critical important here is when the base have 2 factors, when they power, each of them need power separately, right? And then product them together as well. It's also product, it's product, right? Everyone can understand this or not? So we need to add 5 rule here. So A times B, if they have exponent, have n exponent, they have each of the factor, they break it down to each of the factor, need a factor by itself. Right? Right? Okay. So what about this one right now? So we have these rules in your mind. So right now I will change a little bit, is A divided C. B replaced by this one. B replaced by C reversal. All right. So what is it be changed into? What do we change into? Change into this one actually C replaced by here. Yes, B replaced by the C reversal, right? So actually this one you can rewrite C like this. Right? So this became A power n is C power n. So you can see this one equals what? A C n squared. So you can see this is actually quantities, just like a base inside the base. If let's to based on a fraction, the numerator and denominator will power n. Each of the numerator and denominator need the power by itself. So we extended it here a little bit. So A divided C, if the base is made of fraction, each of the numerator, this is numerator, this is denominator, right? Numerator power itself, denominator power itself. Understand? Understand, right? Right. Okay. So we have very this one by one. We just based on the rules. We deduce here, reduce here. So you should be able to understand step by step. All right. So let's move on a little bit further. Right. So we go list out different steps. So we build a lot of rules. So keep this in your mind. These very basic rules. We needed to use it frequently in near soon. We will give some example a little bit later. Actually, we give an example during the time already. Right? Right? Okay. So let's see. Let's see this one. Let's see this one. 6. So A divided C power n. Right? So equals A power n, C power n. Okay. So what about A when A equal 1? When A equal 1. I give like specific example, something like say A equal 1. So here equal 1, like this, right? So this one equals what? Next one equals, do you know this one equals what? Like earlier, what are we doing? So numerator power n, right? C power n. Because here, A equal 1, A replaced by 1, right? So what do you got? So you got a 1 over C power n, right? Because n, 1, any 1 power itself, so equal 1, right? Right? Okay. So, do you know 1? Where did 1 come from? 1 power, actually we can, 1, did you see this one? 1 can be any number itself power 0, right? Do you ever remember this one? This is equal 1. So 1 actually equal power itself power 0. So based on quantum rule, based on this rule, if they are base the same, so they equal 0 minus n, so equal negative n, right? So it means if less a negative, we can write down like this. If less than negative, we can do the reversal. Move all the rest into the denominator. The top is 1, right? So this is very important, called negative exponent. When there's negative exponent, we can change into bottom, change into the denominator. So actually, someone already summarized all what we talked about today here. All right, so let's do some examples. So I will send this out in the handout note. You can review this all process clearly by yourself at home, okay? All right, so let me save this one first, screen first, because that's so critical. So let's see the example in the right part. See some examples here. Can you guys print screen of this one? Before I move on, print screen this one. Print screen this one, all right? And then we will talk the examples. All right, so I will clean the screen. All right, so actually all the power laws already, exponent rules are all here. Let me put the right top corner here so you guys can find here. All right, let's see some examples here. This is very critical, all right? So sum of the exponent. Product rule, power rule, and zero rule, and also about let's call power of product rule and power of quotient rule. We're all talking about and also we'll talk about this one as well, right? And negative rule. So 1, 2, 3, 4, 5, 6, 7. We'll talk about this rule. Just like calculations. Okay, let's see example here. Someone maybe do this before, maybe not. I keep this a question to you guys. We can answer this question later. Which one is bigger? Which one is bigger? Is greater or less or equal? I keep this in your question for your near future to answer. Use some of the rule, you can find out. Maybe let me talk this one. I think this is interesting, right? All right, let's talk about this one. Since this one, maybe you learned this before already. So we know the 3 power 22 and 2 power 33. Which one is bigger? From first view, definitely not easy to find out, right? So we do some proper change. What change? So this one we say 3 square power 11. What about this one? 2 power 3 times 11. All right, so use our earlier power rule. We do the reverse back. You can see this one, we can actually became 2. We can change like this, right? Earlier we say 3 squared power 11. So it became 2 times 11. So right now we reverse back. So this one equals what? 9 power 11. Right? What about right part? We change into 3 times 11. So actually this one is 2 power 3, 11. So this one equal what? 2 power 3, 2 times 2 times 2 equal 8, right? 8 power 11. So you can go quickly to compare this one. This 9 power 11, this is 8 power 11. Definitely this one is bigger, right? Right? Initial, first view, you cannot find out. But right now you can easily to judge. Actually, this is one of the math count questions. Sometimes you maybe met this situation. Okay, let's see second example here. So let's see this one. First, we can see this one is a negative exponent here. So what do we need to do? We make it positive. How to make it positive? Put it in the numerator. We use the negative rule. When they are negative, we put a numerator, put a denominator, right? So this one became positive. Right now, what do we do? So we use the powers of quotient rule, each of them power separately, right? Right? So you can see this is 8, this is 27, right? So 1 divide this fraction. So you got a 27 over 8. Right? Right? All right. Let's see number B. Number B here. Let me use different color so you guys separate can easily figure out. Let's see B here. X power 3 and they are power 4 again and power X and then divide X power 7. You can see the base is the same. So what do we need to do? We need to use the calculation rule. We see top part. Top part X power 3 is 3 times 4, right? 3 times 4. So here it became what? 42, right? 42 times 1. So we can got x power 43 is x power 7. And we use the quotient rule, right? Top minus bottom. So 43 minus 7. So we can got what? 36, right? 36. That's a little bit challenging, right? Not challenging or challenging. Let's see number 3 here. The example. So 3a squared over b divided can power -3. So we need to change -3 to the positive first. The base didn't change, right? So we became positive. This one became positive. The rest we didn't change anything, right? So we use the quotient rule. Use the quotient product rule. Powers of quotient rule. Use this part. This number. This one. So each of them power separately. So this part power 3, right? And this one power 3. So you can see that this part became what? 3 power 3 became 27, right? A squared power 3 became a power 6. The b power 3 became moved to the up. Right? So that's the result. Okay. So this one maybe you guys maybe take a little bit longer time to digest, but it's fine, all right? Just take your time to go through this process. Let's see number D here. For -1x, -3y, and divide for -3x power 2 y -6. So actually, when a negative, you need to switch, just switch, make became the positive, right? So all right, so we need which part, like the base part, the same part can do the calculation. If they are different, we cannot, right? Something like x here, base the same, we can combine this part. Y, we can combine this part. When the base is the same, we can combine, but when the base is different, you cannot combine. Only the base is the same part can combine, right? So actually, we can see this part is 4, this 4, so we combine. So we can, so you can see this is -1, this is -3, so it became 4, -1 minus -3, right? So actually +3. What about the x? X part here became x -3, x here. So we move to the, let's move, keep it in the denominator part. So -3 moved down, here became 3, right? So it became 2 plus 3. What about a y? Y here is 1 actually. They didn't write it out, but actually it's 1, right? So this -6, when they do the reverse, it became top part. So it's going to be 1 plus 6, right? So we organize here. So here is actually 4 power 2. So it became 16. So y 7 x power 5, right? Right. So you can see this one, what changing. So only the base, the same part can combine. Sometimes I ever see some base is different. They cannot do any calculations when the base is different. The condition here is the base the same, you can combine. Base the different, you cannot combine. Right. Okay. Right. So let me 2 more examples before we end this class. All right. Let's see number E here. This E example. All right. So y -3 z 6 power -6. There's a lot of things inside. So what do we do? So firstly, we just change the base. Change the base. When the negative came, that became, all right, became positive. And then next, we'll switch this part. Let this negative become positive. What do we need to do here? So this part don't change it, right? So negative gone. So move the numerator, right? All right. So this part we do the z 6 times 6, right? Y 3 times 6, right? So we just can get it. So this one move up right here. So y 18, z 36. Right? So we get all the negative exponent. All right. Let's see this one. Let me rewrite it one more time. So negative 2 x power 3 and y x y negative 1 power 3. So we not try to consider the power 3 first. We just let the internal, this base part simplify first. All right. So again, negative 2. So x here we use this is basically the same, right? We can combine. So we can x 3 minus 1, right? Became power 2. Y, this is positive 1 minus negative 1. So actually it became power 2, right? So we simplify the base inside first. All right, what's the second? So here, so each of them called a product rule, right? Product rule. This one, powers of a product rule. Actually, this base made of 1, 2, 3. So each of these factors need to be power 3 by itself, right? All right. Right. So you can see here. So here I got a negative 8. Negative 2 times negative 2 times negative 2. So I got negative 8. So what about this one? So x 2 times 3, right? So you got 6. Y 2 times 3, you got 6. And that's the final. So you can simply, these kinds of complicated situation, you can change it into very simplified kinds of expression. All right. So this time actually exponent rule is super critical because so in near future in the Algebra 2 you use this a lot, and in the Algebra 1 only in this section use pretty much, but also very important. So that's all for today. I think the rest examples we can review later, and I will assign this part as the homework, and you can do this one, do more practice. All right, sounds good. Any questions? If no questions, let's stop here today and wish everyone have very happy Thanksgiving holiday, and see you the week after next week. See you later.
Thank you. Bye.
Bye.
Bye.